Okay, guys, sorry I can't be at school today. I promise next Tuesday we'll get the motion sensors out and we'll get to experience those since most of you didn't get a chance to actually do them in class on Thursday. So what I want you to do is I want you to um, split your screen in half here. And so if you need to pause, you pause, rewind whenever you need to today to listen to me and then take the notes at the same time. But I want you to split your screen in half. And when we do that, we're going to pull one tab out, and then we're going to pull it all the way over to the side. So I want the video playing on one side, and then I want you to take your notes over here. So you're going to start a new page of notes called Friction and Gravity, and put your notes over on the other side. Okay, so you have them both sides, so you can still watch the video and see the notes and be able to type at the same time. Alright, so we're going to start with friction. We talked about friction. We read the section the other day in the book. It's the force that two surfaces exert on each other when they rub against each other. Okay, and we did some different things. We talked about where you can rub your hands together to get that heat. That's the friction. Okay. Then when we start talking about gravity, and that's what you were reading about today, the gravitational force, right, is the force that pulls objects toward each other. Everything has a gravitational force. You have a gravitational force. Your pencil has a gravitational force. We just don't feel all of those forces because it's not near as strong as the gravitational force of the Earth. Imagine that you and everything that takes up space, that is matter, has a gravitational force like you're a big magnet. Okay? Some magnets are more powerful than others. The Earth is a very strong magnet, and that's what keeps everything on the ground. You're a magnet, but you're not as strong of a magnet, so most everything is attracted toward the Earth's gravitational force instead of yours. Same thing then with the sun. The sun is has the biggest gravitational force of anything in our solar system, and that's why all of the planets stay in orbit around the sun, is because that gravitational force from the sun, as big as it is, as much mass as it has, keeps every planet in orbit because of that gravity. So everything has that gravity, but the bigger the object, the more mass that it has, the more gravity that it has. And that's why the sun has more gravity than the Earth, and that's why the Earth has more gravity than the moon, because they're different sizes. Now, the distance is going to affect the strength of the gravity. So the sun has more gravitational force on Mercury than it does on Venus. Okay, because of that distance. It still has enough to keep it in orbit, but there's not enough, or there's not as much as there is on the objects that are closer. And remember, you can pause at any time to type these definitions down on your notes, so please make sure that you're getting everything typed in like you're supposed to. We'll move on to mass. Mass and weight get confused with each other all the time. Mass has nothing to do with how much things weigh. Mass is the amount of matter in an object. Okay? We use kilograms for the SI unit of mass, and 1 kilogram is about 400 pennies, like it said in your book. Okay, so the mass of an object, the more mass an object has, the greater its gravitational force. The sun is huge. It has an enormous mass. That's why its gravitational force is greater than the Earth's. The Earth has a huge mass as well, but it's not near as big as the sun's mass. If we look at weight, weight then is the force of gravity on a person or object at the surface of a planet. So when you step on that scale, it's telling you how much force of gravity is pulling you down. And that's why if you go to the moon, you're going to have a different weight. If you go to Mars, you're going to have a different weight. Because of that gravitational pull is different on every planet. So we need to make sure that we keep mass and weight separate. Mass is the amount of matter. Mass, matter. Okay? Use that similarity in words. This is the vowel sound there to help you remember. Mass, matter. Weight, then, is the force of gravity. And the last thing is the air resistance. It's the type of friction objects falling through the air experience. Okay, so like it said in the book, you've seen leaves, they just kind of flutter to the ground. Okay, if you were to take a marble and a feather, the marble's going to hit first because of the air resistance. However, if we were to put those in a vacuum where there's absolutely no air, they would both fall at the same time. Okay, that free fall that we talked about in the book, everything falls at the same time. If you were to take 1/4 and then you're going to take 2 quarters taped together, push them off the desk at the same time, they're going to land at the same time. Okay, that free fall is the force of gravity that causes an object to accelerate. So they're going to accelerate at the same time, unless there's air resistance. Okay, things like the leaves and the feathers have more air resistance because they're bigger. They have more surface area. There's more for that upward air resistance to push on a leaf than there is on an acorn. Alright, now that you've got all the notes, what I want you to do is I want you to go to Quizlet if there's time left in class, and I want you to add friction, gravitational force, mass, and weight to your Quizlet stack. You don't need to add air resistance, just those first 4 from today's notes. Add those to Quizlet, and then if there's still time left, practice your Quizlet. Have a great day, guys. Have a great weekend. I'll see you next week.